Before we move on to fix our refinement model M2 even further, I would like to recap what we actually achieved from the last part. It's always important to know about where we are at the moment. And remember, we introduced this extra invariance number 5, which is about the two traffic lights on the island side and on the mainland side. They cannot be green at the same time. And thanks to this extra invariance, which will be added as a new hypothesis in the proof sequence, we were able to discharge two proof sequences related to invariant preservation. One is about ML out, invariant 2.4. The other one is about IL out, invariant 2.3. If you have any doubts about these two proof obligations, you can refer to the earlier part. We got a complete discussion about it. And for now, we're going to talk about the second case, about what's going to be the consequence of this new invariance that being added. Every time you add a new invariance, you have to worry about what kind of sequence that we have generated or that we haven't generated should be impacted. That's something we're going to discuss. The second case, right? So this is something we talked about as a second case just earlier. Additional 6 times 1 sequence are to be generated due to this due to this new invariance. How does the math work? Why 6 to 1? The 6 over here is about the 6 events we have in M2. And the 1 over here is referring to the extra new invariance condition number 5, right? That's why we got 6 in total that's to be generated for this new invariant. And we want to make sure this invariance can be preserved by all the existing 6 events. And we're not going to discuss all of them, but only 2 of them. And we're just going to talk about how we can formulate the sequence to be proved. And the proof themselves will be up to you as exercises. That's what I would like to give you some guidance about. We're going to talk about these 2 over here. Specifically, we're talking about the 2 new events. One is called MLTL green. Remember this events over here, its occurrence suggests the traffic lights on the mainland side will be turned green. And symmetrically, there is another traffic light on the island side, and the occurrence of this event over here suggests the traffic light on the island side will be turned green. And we want to make sure these 2 new events that we introduced in M2, they will both be able to preserve the new invariance that we spoke about, right? This invariant over here. In some way, it makes sense because these are the only 2 events in M2 that will change the states of the traffic lights. Other events are mainly to change the variables A, B, and C, right? If you can look up to the model that we spoke about earlier, you will see. Right, so now we want to see how these 2 events can really preserve the new invariance 2.5. And what we will do is we're going to formulate the invariance together, right? We need to revise the 2 events. Okay, so I'm going to tell you the conclusion already. So if we simply use the action for these 2 events as is, we wouldn't be able to discharge the preservation of invariant 2.5. Let me show to you what I meant. Okay, over here. The existing actions for these 2 events, for example, MLTL green, you will only try to turn the MLTL to be green. That's the existing action. And for ILTL to be green, we just assign the corresponding variable to be green. However, we actually have to revise the actions by adding one more action that's kind of symmetric, meaning that whenever we turn the traffic lights on the mainland side to be green, we want to make sure we turn off the traffic lights for the other side of the bridge, right? Similarly, or symmetrically, if we want to turn the traffic light on the island side to be green, we want to make sure we turned the traffic light on the other end on the island to be red. So these 2 actions, which I highlighted in red, are the ones that are missing from our earlier action. Okay, so these 2 are to be added. If you didn't have these 2 actions added, you wouldn't be able to prove these 2 proof obligation about MLTL green preserving invariant 2.5 and also ILTL green preserving 2.5. Okay, so there are 2 things I would like you to do. Number 1, you're going to somehow try to prove the preservation of invariant 2.5 with the revised actions over here. Just make sure you will be able to prove the sequence. Number 1. Number 2, also as exercise, you also want to see what if I got rid of this new action over here, which is kind of the revision we are suggesting. Hypothetically, without these 2 new actions, will you be able to preserve invariant 2.5? Will you be able to prove the corresponding sequence? If the answer is yes, then what's really the point of adding these 2 actions, right? So the answer should be no. without these two actions, you should not be able to prove the two sequence. That's really the confirmation I would like you to really draw formally. Okay. And for now, I'm just gonna give you a little bit guidance over here to see how we can formulate the sequence to prove. Let's do that quickly, and then I'll leave the proofs to you. Okay, let's now move on to this part over here. Okay, and let's say we have already revised the actions by adding the symmetric, turning the other side to be red. Okay, let's see what we can do. Let's say we want to formulate the sequence for MLTL green for invariant 2,5 and invariance. This part over here have done that already for you. The relevant axiom and also the invariance for model 0, for model 1, and also for model 2. So these are all there, right? They are all in place. Of course, if you were asked to really do this invariant formulation in the exam or test, you should know where to draw them from. We have done many exercises relevant to this already. Right? So what's really missing from the hypothesis? We've got everything over here. All we need now will be the concrete guard for the events, which would be, let's say here we're talking about MLTL green. So that means we need to put in the concrete guard for MLTL green. That's what we should do, right? Let's write it down. It would be MLTL equals red. A plus B less than D, and also C equal to 0, right? So this part over here is really concrete guards. Okay, let me just write it a little bit better. So these are the concrete guards of the events, in which case you'll be MLTL green. And then, so these are all the hypotheses. We're gonna get turnstile. What should be the goal? And the goal over here should be somehow replaced by the post-state value of the concrete invariance, invariant 2,5, which we're trying to formulate, right? Let me say start over here. Let's try to work out the logic over here as usual. Let me put it here. The start should be, and this is the invariance that we are trying to formulate. Let me just go back there, right? You can see this is the invariant. MLTL should be red, ILTL should be red, right? So the post-state version. So there should be MLTL prime equals red, or ILTL prime equals red. So that'll be the conceptual version. However, you should really replace the TL prime over here and also the TL prime by according to the before-after predicate. So what's really the before-after predicate? Let's take a look. For this event over here, we know that the before-after predicate should be MLTL prime equals green, I'll say G, and also ILTL prime equals R, right, the red, and also A prime equals to A, B prime equals to B, and C prime equal to C, right? Remember, all the variables not really mentioned, they should be maintaining their value from the pre-states. So now we can really replace MLTL prime should be green. So this part over here should be green. ILTL prime should be red over here. All right, sorry. ILTL should be red over here. Right, let's now put it down. It will be now, let me use in purple, the green equals red, or red equals red. Right? I can already see a proof from this quite easily, right? But I'm going to leave that as an exercise for you. Find out the relevant inference rule to really prove this. Of course, you cannot just say this is already proved automatically. No, because you got such a giant set of hypotheses. You want to use the relevant rule to drop them and then to really identify the relevant pattern to really discharge the sequence. I think we should really do in due formal process. So this will be your exercise. Let me write it out explicitly to really remind you. Exercise, which is to do the proof. And not only that you want to prove this sequence that we already formulated over here, but also you want to also specify the other new events preserving this same invariance number 5 and also prove it. That'll be your exercises, right? So complete the exercise before you actually move on to the next part, where we will try to fix the model even further.